All right, example number 3, differentiating expressions involving natural logarithm. You notice we have the natural logarithm of this quantity in the brackets. Now, identifying the structure of that expression in the brackets is pretty important here. And again, I'll take you back to these logarithm properties. Hopefully you realize that the expression inside here has multiplication going on. It's this quantity times that quantity. Now in hindsight, when typing up my notes, I suppose I should have put the fact that that's an A times a B. Isn't there a big green multiplied dot between the A and the B there? All right, so the point is we're taking the natural logarithm of a product, and it would in fact be of benefit, it would behoove us to apply this algebra rewrite to this particular question. We have the natural log of a product. So before we start doing calculus here, why don't we say, okay, when you have the natural log of one thing times another, according to algebra, that would be the natural log of the first quantity plus the natural log of the second quantity. Now, that's not a calculus rule. That's not the product rule for derivative. That's the product property from algebra for logarithms. So, I hope you would recognize that. When you're taking the logarithm of a product, A times B, you can put log of the first factor plus log of the second. What else maybe might happen? Now you hopefully realize that each of these individual logarithms, I'm not even doing calculus yet. You know why? Because this first one is now what? The natural log of something to a power! Now we can jump up here and do that power property to each of these logarithms. And therefore, this can be 3 times the natural log of 2x minus 4. Notice what happened, that power came down in front. That power can be brought down in front. This really sets the stage nicely for calculus. And similarly, that second one, the power can be brought down in front. That would be an application of the power property from algebra of logarithms. I believe at this point, now, one thing you might say is, oh, there's minus here, oh, there's minus, and things like that. But no, there is no natural log A minus B. That's natural log A, natural log B. My point is, I think we're done as far as algebra rewrites. And so now, we would hopefully at this point go, I'm ready to do me some calculus. Notice this guy wrote F prime here. And derivatives. 3 is a coefficient. There's no product rule necessary here. That's just a number. 3. Chain. Natural log is external. What's its derivative rule? 1 over. So that'll give us 1 over 2x minus 4. That's the derivative for this. And then the internal, which would be 2. Right? Inside. Easy. Plus, different term. 2, that's just a coefficient. Oh, here we go again, just like the one right in front. You're outside. Chain. 1 over 5x plus 6. And then the derivative of what's inside, which is 5. Boom. You don't need to clean it up. I'm good. Okay? So I'd say that's good on that one. While we're on a roll, why don't we go back and do this one here. Then we'll pause and catch our breath here for a little bit. So, again, hit pause, do whatever you need to do, and you can kind of take some time looking at that. I hope you wrote it down, look at it here. I'm ready to erase it and begin enjoying the next one. So again, I don't think there's an issue of me going too fast, because again, you can always pause, or you can rewind and watch it again, things like that. I'm trying to work at a fairly reasonable pace. So, all right, now, I think there's a couple of things going on here. The natural log of the cube root of fraction. Let's just call it that. Well, I would hope your first instinct would be to say that since that's the cube root of the fraction, couldn't that be written as fraction to the 1/3 power? We have been all semester changing radicals into fractional exponents. And that hopefully is an instinctive thing at this point. Now, what else could a person do? These aren't instincts yet. They've been introduced today. But after changing that to a fractional exponent, my hope would be you go, we now have the natural log of something to a power. The natural log of something to a power, let's bring that power down in front. And look, these are very, very beneficial algebra maneuvers. I hope you understand what's happening here as we just employed that power property of logarithms, which is an algebra thing. Natural log of something to a power. Power can be brought down in front. That removes one calculus step from the question. I would also hope at this point, why didn't he put prime? I'm going to do more algebra. Because after we brought that power down in front, don't we now have the natural logarithm of a fraction? An a over b situation. Indeed we do. All right? So, wouldn't that be the natural log of the numerator minus the natural log of the denominator? The natural log of the numerator, now this is an easy thing to mess up, minus, we have to remember that that 1/3 was in front of this, so that 1/3 would be distributed to each of those. So if you take 1/3 times the natural log of numerator minus natural log of denominator, let's remember to distribute that 1/3 to both of them. There's that. And you know what? This really makes the calculus f prime. I'm ready to do me some calculus now. This is just a coefficient. Chain. Outside. What's the derivative of natural log of something? Now we're doing calculus. Right? And again, that derivative rule would be the 1 over. So we have 1 over 4x minus 1. And then inside would be 4. Make sure to take the chain rule to its full extent. We got it kind of wrong if you forget to put that 4 there. Minus coefficient, numerical multiplier. 1, 2, 3. Chain. 1 over derivative of what's inside. Bang. This really did work a lot better doing those algebra rewrites before we got into that. So, I think that takes care of those two examples. And I think we'll pause here, and then there's 2 more on this slide that we'll come back and enjoy together, all right? You rock on. Here we go.